The APU is a self-contained gas turbine engine located in the airplane tail cone. The APU provides an alternate electrical and pneumatic power source on the ground and in flight. Electrical power is available up to the airplane's certified altitude, with pneumatic bleed air available up to approximately 17,000 feet. The APU supplies pressurized air for engine starting and for maintaining cabin air conditioning during ground operations. Actual operation of the APU is controlled by an APU controller, which coordinates the starting sequence of various APU components, monitors the operation and pneumatic output of the APU, and ensures protective shutdown. The APU control panel contains one rotary selector and two annunciator lights. The selector is used to start the APU and also to shut it down. The run light is used to monitor the APU start operation and the APU's readiness to deliver electrical and pneumatic power. The amber fault light may come on for any number of reasons that cause an APU shutdown, but is also used to monitor the APU fuel valve operation. While the APU shutdown for a fire condition is automatic, the discharge of the agent bottles must be manually performed either in the cockpit or on the external remote control panel by the nose gear. On this frame, click the yellow buttons to locate each item on the graphic. Then click Next to answer some questions.
Two batteries are required to start the APU battery and the aircraft battery. The APU battery powers the APU starter motor, the APU control circuitry, and operates the air inlet door.
The aircraft battery supplies power for fire protection, the APU fuel valve, and the DC fuel pump in the left main tank if there is no AC power on the airplane to activate the left main tank forward AC fuel pump. It also serves as a backup source for the control circuitry if the APU battery drops too low because of heavy starter motor load.
Rotating the APU selector to start and then releasing the selector to on begins the automatic start sequence. The APU fuel valve opens. At the same time, the air inlet door begins to open and a fuel pump also begins to operate. When the air inlet door is fully open, the electric starter engages. At the proper speeds, ignition and fuel are provided and the APU accelerates to its normal speed. The starting sequence can, in part, be observed on the control panel. As the APU starts, the run light blinks twice in quick succession as an indication of a self-test of the control circuitry. Immediately thereafter, the fault light comes on and goes off as an indication that the fuel valve opened. Well, after another time interval, the run light illuminates steady to indicate that the APU is at operating speed and may now be used to supply electrical power and bleed air. The acceleration of the APU to operating speed can also be observed on the status page of the lower ICAS display. EGT, RPM, and oil quantity can be observed on this page at any time. The APU starter duty cycle is a maximum of 3 consecutive starts within a 60-minute period. To protect the APU from thermal shock, the APU control system incorporates a time delay feature which permits APU cooling before shutdown. Now, if the APU is supplying pneumatic power at the time of shutdown, the APU bleed valve closes first, and the APU shutdown is delayed for 60 to 120 seconds. If the APU bleed valve has been closed for more than 60 seconds at the time of shutdown, the APU shuts down with no delay. If the APU is inadvertently shut down, but the run light is still illuminated, the shutdown cycle can be canceled by momentarily rotating the APU selector to start, then release to run. Normally, the APU is shut down with the APU selector, and the cool-down cycle operates as described. On the ground, pushing the battery switch to off will also shut down the APU. However, the APU continues to operate through its normal cool-down cycle before it shuts down. Now, attempting to shut down the APU by use of the battery switch is not a legitimate way of shutting down the APU, because it could result in loss of fire detection if the APU continues to operate for the cool-down cycle when the battery switch has turned off the fire detection. In flight, the position or selection of the battery switch has no effect on APU operation. The amber fault light on the APU panel illuminates whenever a fault is sensed. Concurrently, an ICAS advisory message of APU fault is displayed, and the APU shuts down immediately. The normal cool-down cycle is eliminated. This fault indication can be extinguished. When the APU selector is positioned to off, both the fault light and the APU fault ICAS message disappear. The fault light also comes on when the APU fuel valve is not in the commanded position. Therefore, during APU starts and shutdowns, the fault light will be on momentarily because, momentarily, the fuel valve disagrees with the APU selector position, on or off. If the fuel valve does indeed not reach its signal position during APU start, the ICAS advisory message APU fuel valve appears. Again, this fault indication is extinguished when the APU selector is moved to off. On the other hand, when the APU is shut down and the fuel valve does not close, the fault light and the ICAS advisory of APU fuel valve remain displayed continuously.
The APU fire protection system includes the following: fire detection, fire warning, fire extinguishing. APU fire detection. A dual-loop detector system is installed in strategic locations for the detection of an APU fire. Overheat detection is not provided for the APU. If an APU fire is detected, the APU automatically shuts down. Normally, both loops must detect a fire before a fire signal is generated. This is referred to as AND logic, meaning one loop and the other loop must both detect a fire to provide a fire warning. In the event of a single loop failure, automatic switching to the single loop mode occurs. In this case, the remaining operative loop is capable of generating the fire signal if a fire is detected. In the event of a failure of both loops, a fault indication is provided by the sysfail light and ICAS advisory message of Fire Overheat System. Pressing the sysfail switch light will reset the system to monitor other detectors. Some aircraft have the following option. On the ground, with engines off, the system operates with OR logic instead of AND logic. In this case, a detected fire by either loop will activate the fire warning. If an APU fire is detected, the APU automatically shuts down. APU fire warning. An APU fire is indicated by the fire bell, the master warning lights, the APU fire handle, the discrete fire warning light, and ICAS warning message of APU fire. In addition, the APU automatically shuts down, indicated by the APU control panel fault light, and the APU fire handle is unlocked. In addition to the above fire warnings, if the airplane is on the ground, the APU fire warning horn on the nose gear strut sounds, and the APU fire light on the APU ground control panel illuminates. The fire warning lights remain illuminated as long as the fire persists. The fire bell and master warning lights can be canceled by pressing a master warning caution switch. The fire bell and on the ground, the fire warning horn can be silenced by pulling the APU fire handle or pushing the APU shutdown switch on the APU ground control panel. APU fire extinguishing. There is one fire bottle installed to provide APU fire extinguishing. Pulling the APU fire handle arms the discharge squib on the APU fire bottle. Rotation of the APU fire handle in either direction will discharge the bottle into the APU compartment. When the APU bottle has been discharged and is low on pressure, the bottle discharge light comes on and the associated ICAS advisory message APU bottle is displayed. There are two fire bottles installed to provide APU fire extinguishing. Pulling the APU fire handle arms the discharge squibs on the APU fire bottles. Rotation of the APU fire handle to left or right will discharge the respective bottle into the APU compartment. Note the bottle discharge lights and ICAS advisory messages for these bottles.